to find out which area are they talking about. So graphing is crucial. And graphing, not only just graphing kind of a tiny little graph that's not going to help you. Give yourself some space, graph something that is decent so you can see which region they are talking about. Okay? And then you'll be able to kind of look on how I'm going to calculate the area. So graphing, the first part is crucial. Okay? So let's see if we can do a nice graph of this here. I know that this is a line. That's a line. Now this is a parabola, but notice that the square term is the y. And since this is a 2 in front of the x, so it's a parabola that's going to be opening to the right. It's not going to be opening up or down, because the y is the term that is squared, so it's going to be a parabola that's open to the right. So just imagine, if I have a parabola like this, and a line is going to intersect it, that's the region they must be talking about. So the first thing I do, I'm going to cheat a little bit. I want to find out where does these two things intersect. Because after all, that's going to be important in my calculation. Okay? So let's do the intersection of these two guys. If I want to set this equal to each other, I would like to find out where do they intersect. All right, so let's solve this following system. If y is equal to x minus 1, then x is equal to y plus 1 in here. You read? And if I plug that inside the second equation, then the second equation would read y squared equal to 2 times y plus 1 plus 6. Okay, so all I did is in the first equation, we have to have the x equal to y plus 1. And therefore, if I replace this x by y plus 1 in the second equation, this is what it says. And now I can solve for y here. This is y squared minus 2y, and then we have a plus 2 plus 6 is a plus 8. On this side becomes a minus 8 equal to 0. All right? So the y squared minus 2y minus 8 has to be equal to 0 at the point of intersection. And what values of y can I get out of this? You can use quadratic formula, or you can just factor it. Okay? In this case, I need the product of two numbers, minus 8, and the sum of minus 2. Minus 4 and plus 2 will do. So what does that tell me? Well, it tells me that what are my 2 points of intersection that these guys, because remember, I visualized already that one of the parabola is going to go like this. The line is going to go like this. So they must intersect at 2 points. So here are the 2 points. Okay? So the first point has a y coordinate equal to 4. Really? Because this is equal to 0 when y is 4. And the second point has a y coordinate equal to minus 2. So how do I find the x coordinates now? X is always y plus 1. Because you're on the line. Well, on the line says the x coordinate of a point is always equal to the y coordinate plus 1. So if the y is equal to 5, the x must be, y is equal to 4, then the x has to be 5. And if the y is minus 2, the x has to be a minus 1, because you add the 1 to the y. Okay? Therefore, those are my 2 points of intersection. So let me put them. And it's a nice approach to do the parabola, because then you can get a decent graph. So this is 5. This is 4. And I get this point here. That's 1 point of intersection between these two things. Okay? The second point is minus 1 minus 2. So here's minus 1, and here's minus 2. That's the second point. Okay? As a matter of fact, I can draw the line. The line y equal x minus 1, everybody knows, is just going to be this line. It's just going to pass through this, pass through here, pass through here. That's the line y equal x minus 1. It's going to, because we found 2 points of intersection, 2 points determine the line already. Okay? And now the parabola, I know the parabola is going to go like this, guys. Because it's got to intersect the line at those points. Okay? So let's find one more point on the parabola that will help us at least. If I put y equals 0, if y is equal to 0, then x would be equal to minus 3. Can you see that? Because 2 times minus 3 plus 6 would be 0. So let's put y equals 0 and x equals minus 3. That's this guy here. So that's a third point for my parabola. So I can do a halfway decent job of graphing the parabola now. That's basically the vertex, okay? soon enough. Here we go. Okay? Now I said that in class, the last time I said that if you want to calculate the area like that, you have to think of it as being made up of slices. Now you have two choices here. You can ask yourself, can I think of that area as being made up of vertical slices or horizontal slices? One way is easier than the other. Okay? Let me explain. If I were to think of this using vertical slices, I think I'd be complicating life more than I should. Why? Because look at this. If you think of this area bounded is made up of vertical slices, you say, okay, let's take a typical slice. Let's say this one here. That's a typical vertical slice. You mean, when I say typical, what does that mean? It means it's positioned at some position x. You agree? If somebody asks, what is the area of that slice? Well, let's see, dx. What is the height of the slice? It's the height to the parabola minus the height to the line. Are you with me, guys? That would be the formula you would use for that slice. But suppose another student says, oh, I want to take my typical slice right here. And you cannot stop that student and say, oh, I want to take my typical slice right here. Okay, that's a slice also that is vertical. You with me, guys? Position the x here. What is the area of that slice? dx times the height. But now notice that the height is the height of this branch of the parabola minus the height of this branch of the parabola. So notice that the formula of the slices changed as we moved across this region. You mean? So that tells you that maybe it's not the approach that I would like to do. I'll do this in a second. I'll do this second approach to show it can be done, but it's a more complicated way to get the answer, which is easier to do the other way. Okay? So basically, doing vertical slices is not the way to go in this problem. So let's use horizontal slices. So I want to take a typical horizontal slice. Let's say this one here. That's a typical horizontal slice. What do I mean by typical horizontal slice? What I mean by it is I know where it's positioned. It's positioned at height y. This is y. That's what it means to have a typical horizontal slice. Because a horizontal slice, you can locate it by telling me how high it is. So it's y coordinate. A vertical slice, you can locate it by telling me about the x coordinate. You hear me, guys? So here's a typical horizontal slice. Now, what is the area of that slice? Let's call it dA. dA, that's the area of that slice. What is the width? dy, okay? dy. So this tells me right away that I'm going to be doing some integration with respect to y. So the width is dy. I'll write it in a second, okay? Keep that in mind, okay? Now, what is the length of this slice? The length for this value of y, the length of the slice is this x coordinate on the line minus the x coordinate of a point on the parabola. You mean, guys? So let's write it that way so we can it's x coordinate of that point on the line minus the x coordinate of the point on the parabola, and you multiply by that by the width dy. So the question now, since I'm going to be doing integration with respect to y, I better change these guys into y's. You hear me, guys? Because I'm going to be doing integration with respect to y, so I better change these in terms of y's. All right. If somebody gives me this height y, what is the x coordinate of the point on the line? If you give me y, what is x? X is y plus 1. You agree? Minus. If you give me this height, y, what is this x coordinate of the point on the parabola? You give me this y, what is the x coordinate of the point on the parabola? Y squared minus 6 divided by 2. You hear me, guys? Can you see that? Y squared minus 6 divided by 2. Okay? That's the x-coordinate of the point on the line. This is the x-coordinate of the point on the parabola, written in y. Y. That is the area of that horizontal slice. Now, this region already is made up of infinitely many of these horizontal slices. The first one is going to be right here. And I'm going to be adding over all these horizontal slices. Okay? I found the area of the typical one. So to find the total area, all I have to do is add over all the areas. Add infinitely many things, makes integrate. The typical slice has y plus 1 minus y squared minus 6 over 2 dy. And now where are we going to be adding these slices from what to what? The first slice is positioned right here at this point of intersection, you hear me guys? And that's when the y is minus 2. Okay? The y, notice, is minus 2. And then your slices, you're going to be adding them until the y reaches what height? Until it reaches the y coordinate of that second point of intersection, which we said is 4. Now, this integral is not that bad to do by hand. I mean, you can find the antiderivatives of powers of y here, by minus 2 and 4, and we are done. We have found the area, and we're done. You get me, guys? I'll do it in a second with Maple to calculate the value. Okay? But just to tell you that, if you persisted on using vertical slices, you could still work the problem, but it's going to be a little bit longer.